Oh, I forgot to push the button that says go live. We're live a second time. I swear I pushed the button. Here, man. Sorry about that, guys. We are live. I'm halfway into the questions already. Oh, man. So sorry. I started without you. I forgot to push the button to go live. Well, anyway, we are here, and I got to start over because I made a big announcement, and the people that are live, they missed it. No audio, just micro mark commercials. What? Hello, Ben. Can you hear me out there? Oh, man. My mic is on, and I am showing that it's working. Can you hear my mic? Microphone. Microphone. What is going on here? Microphone. There we go. Yes, Ben says yes. Thank you, Ben. All right, we are live. Okay, so this is RockSim Live. My name is Tim. You're watching my computer screen right now. Next week, which I announced earlier, which you didn't hear, we're going to try something a little bit different in this live presentation. Instead of talking about RockSim, we're going to do a show and tell, kind of like a behind the scenes at Apogee Components. I'm going to, as a topic, I'm going to bring out my range box and we'll go through my range box, and we'll set up the studio a little bit different, so hopefully I can have multiple cameras going so you can see, you know, different views and that kind of thing. So now we are getting questions. Meg Wesley says, what's the biggest rocket you can simulate in this program? And the answer is, I don't think there's a limit, because the laws of physics don't change. So as long as you have a rocket motor file for the rocket, you could simulate anything pretty big. But you have to remember that this program is designed for suborbital rockets. Anything that goes into orbit around the Earth, it's not going to do. So you can't do like a Falcon 9 full size that goes into orbit, but you can do like a sounding rocket like NASA. So that's kind of the limitations on how big. Johan says, yeah, we can hear you. Fat Bank says, good afternoon from Texas. Meg Wesley says, also, does this program have a way to simulate custom-built engines to see if they work correctly? Well, to answer that question, because I already answered it once already, but that was before the microphone and the camera got turned on. Last week, I was going through my tutorials from last week, and last week we were talking about adding a motor not on the thrust curve list. So if you have a motor file and you want to add it to RockSim, it is possible, but the version that I have, I can't do it because it keeps crashing on me. So the answer is we did build in that functionality to do any size rocket motor, but I can't show it to you today. So hopefully in a future episode I can show that to you so that you can see how to do it. But it is theoretically possible. All you need is an engine file. And RockSim will use two different formats. It will use the RASP format, which was an old G. Harry Stein that was in his book, Handbook of Model Rocketry. He created that format, and it was RASP, stands for Rocket Altitude Simulation Program. And it was it DOS? No, I think it was BASIC, the program that it was written in. This was like 40 years ago. So since then, things have changed. That format of engine file is still around. People still use it, but we in RockSim prefer the RockSim format because it contains a lot more information about the rocket engines. Meg Wesley says, does Apogee make or sell a program that can simulate engines? Like, so you can test different nozzle sizes or case sizes? No. Yes? No. The engine edit program starts with a thrust curve. So if you're looking for a program that will create a thrust curve based on the motor geometry and the nozzle size and the case length and the case size, that's not what we do here. There is a program like that, but I forget the name of it. I'm sure if you Google it, you'll find something. And then, so those programs, what they output is a thrust curve. If from your perspective, a thrust curve, where 0 is here and a number of seconds later is out here. And then you got the thrust curve, and those programs will generate that. But once you have that, then you need to bring that into a program like RockSim, which is what does those simulations. So once you have the motor file, then you can bring it into RockSim. And like I said, there's 2 different formats that RockSim can read, RASP and the RockSim format. The RockSim format ends, the extension on the file name is .rse, which stands for RockSim Engine. So that's what that stands for. Very good question there. I wish I could demonstrate engine edit. Engine edit comes with RockSim, but mine was not working. Let me see if I can, let's try to bring it up. Let me go here. Let's see, like a really old version. 3 RockSim Pro, Engine Edit Pro. Engine Edit Pro and Engine Edit are exactly the same. There's no difference. We put Engine Edit into both RockSim and RockSim Pro because both need engine files. See, I was getting this error that it was crashing. See, in my file, I got a whole bunch of different versions. Okay, so this is what engine edit looks like. When you first start, it's blank, and to create a new engine, you would go here. See, what this is looking for is an engine thrust curve. You have to generate the thrust curve yourself or measure it on a thrust stand. So, like I could say 20 newtons and see what happens. So, so here's the thrust in newtons, and then here's seconds, and then you just click on the graph. I should be able to click on the graph. There we go. To add points. But this one, like I said, my engine edit for some reason is not working right. But that's kind of a thrust curve, and it will calculate the total impulse. And then you can, save the information, the diameter, the length, and the mass, the propellant mass, and that creates the engine file. And then in RockSim, that will open those up. But we're not going to talk about engine edit today because it's crashing. It's too embarrassing. Okay, we got another question over here. He says, Meg Wesley says, all right, thanks for the info. Back to my shed to continue my Class 3 rocket project. Though because of weird laws in my local area, I can launch and build it without any certification. That's possible in some locations, especially if you're outside the United States. Your program will be very useful. Fat Bank says, is there any way to account for curvature fairings designed for tubing like the Aerobee 150A? I use custom fin module because the object doesn't match the curvature of the tubing. Curvature fairings. I'm not sure what he means. Let's see. So I'm going to go on Google and I'm going to type in an Aerobee 150A and see what this looks like. Okay, so here's the Aerobee. That's an Aerobee High. I don't know if that's the Aerobee 150A. I'm looking for Aerobee 150. Let me go back. Get out of 3-inch Aerobee 150A, Mad Cow Rocketry. Okay. Oops, I screwed that up. I was trying to get a bigger picture and it didn't work. So I think he's talking about these fairings right here. Curved fair. I guess if you're, so those are kind of rounded on the top. Is that what you mean, Fat Bank? If the unfortunate thing is that we can't simulate these in RockSim. Yeah, we can do a side profile, but not the top profile, especially that rounded front end right there. We won't be able to do that. That's beyond the capability. So like what you were doing there, Fat Bank, is using a custom fin. That's probably as close as you're going to get. And for simulation purposes, that's actually not too bad. I don't think you have to worry about it too much. Carlos says, range box show request. If you have a rocket fin preservation during travel hints, please include that too. I am tired of busted fins. Okay, so what he's asking is, okay, you got your rocket and you're going to take your rocket to the range and you got to get it, transport it to the range without busting fins. Okay, so that's a good question. It depends on how far I'm going. You know how I would pack my rockets. If I'm just going to my local launch, I don't think it's been a long time since I busted a fin before I got out to the range. But if I was going like across the country or out of state, yeah, I would probably pack them a little bit different because they're going to get jostled a lot more because you never know what the roads are in eastern Colorado. David Bloomquist. Hello, David. Can you override the mass on a subcomponent, i.e. booster airframe, or just the individual components? Booster airframe or just the individual components? Subcomponents. That's a good question. And Fat Bank says, I mean the mating surfaces, the fairing base to the tube surface. So, there's, the tube is round, so you have to curve it this way. Again, RockSim, when RockSim attaches it, it's just fine. No, but it doesn't curve this way on the tube. on the nose cone, it will curve along the curvature of the nose cone this way, but not this way, going around the perimeter. That's just a limitation in RockSim. And again, that's more of a cosmetic issue in RockSim rather than a simulation issue, because they're going to sim pretty close. It's going to be in the ballpark. So let's do subcomponents. Let's open a design. Now, if you're talking like a subassembly, are you talking about a subassembly, David? I'm trying to reconcile an existing RockSim file to my actual weights. Okay. In that case, David, yes, RockSim will allow you to do. There's a number of ways to do mass in RockSim. This is a very, very common question. And if I screw up, which is totally possible, if you go to the Apogee website, did I close my browser? I must have. Again, on the Apogee website, if you want to get to the archives, just click here, and then you come up to, these are the previous episodes, and you can, like we talk about the mass and the weight a lot. And so on this page, you'll see it a lot. One of the quick ways to find things on this page is do a Control F or Command F on the Macintosh, and it brings up a search bar at the top that will just search this particular page. So if you do mass override, it shows that there's 5 occurrences of it. So you can always watch those, but I will go through this here live because you are here right now and you want to know. So, so here's my rocket. I got this Lodestar, and RockSim is telling me that the mass is 95 grams, and you weigh your rocket, and it weighs 100 grams. And so how can you account for that difference in mass? Because this is important, because it has a big effect on the altitude of the rocket. So the quickest way, but the least accurate, and I mean not accurate as far as how high the rocket flies, it's what path the rocket flies, because the mass is important to how high it goes, but where the mass on the rocket is located is going to determine the moment of inertia of the rocket and how the rocket reacts to wind. And if your mass is not in the right spot, you're going to get a different moment of inertia, and the trajectory path could be different. But if there's no wind, it's going to be identical, so then you don't have to worry about it. It's only if you have wind, and what rocket does not fly in the wind? So you could use mass override, and as I said, this is my least favorite way, but it can be done really quick, because you just weigh the rocket, and you say, there's a little checkbox right up here that says use the value shown below for all the simulations. And right now, you can see the mass down here is 95.4 grams. And if I wanted it to be 100 grams, I just type in 100 grams here for the sustainer. But then you also have to put in the center of gravity. So then you have to weigh your rocket. And you do this without any engine installed. So there's no motor in the back. And you just balance it on your finger, and you find out where it balances. And then from there, you measure from the tip of the nose cone to where it balances, and that's the number you put in here on the sustainer. This is a different rocket here on the screen, so I don't know. I wouldn't use this rocket right here that I'm holding, because it's a different rocket, but you use that sustainer location and you type it in. So then you have your CG is in the right spot, And then you can run your simulations, and it'll work really good. But if you want to get a bit more accurate, instead of using that, so then you have to uncheck this, let RockSim calculate it. Then you can go to each of the design components, and then in the design components, there's two ways to do things. First, again, you can come here to mass override. There's a tab for the mass override for the component, and you can change that. Again, you have to check the little box that says use the mass and the CG information below. And this time, it's only for the nose cone or whatever component you're working on. So then you'd put in a mass and a center of gravity location. And as soon as you check that little box, over here, there's going to be a little message that pops up that says mass override turned on. So like I click it, it says mass override is on. That's really the only way to tell that you're using that feature. Okay, so I'm going to uncheck that, and that will go away. And then the third way is to actually change the mass distribution based on the material and the material density. And this is the hardest way, but it's the most accurate for that trajectory that we were talking about. So you would go to the General tab. You have a material here. This is polystyrene. And then you have the construction and hollow, and those, the density, the wall thickness, and the shape determines a volume, and it multiplies the volume times the density, and that gives you this mass right here. And so if you want to adjust that mass without using the mass override, you can either adjust the material or, excuse me, the thickness of the part. So if I made it a thicker part, you'd see that mass jump up. So I'm going to make it like 0.7, then hit tab, and you can see it jumped way up. You know, it jumped up like 6 grams there. So that is what you could do there. You could also go into the database and edit the density of the material. So if you wanted to do that, so I just canceled out of the nose cone, and then you would come up here to Rocket, come down here to edit database, and then you come across and edit the materials. And then this brings up the database of materials editor, and you'll see, like, let me scroll down till I get to the polystyrene. Okay, so here's that polystyrene, and it tells us the density of the material. So what you could do, if you know the wall thickness is right, then you could come back here and adjust the density, but I don't know anybody that ever adjusts the density. But it's possible. You could just adjust that density and then click OK, and then it would change. So right now, let me like change this density to 90 instead of 65.5. Uh, 90 pounds per cubic foot. That's so like it's real heavy. Then click done, and OK, and come back here to the nose cone. And before, let me choose a different material, acrylic, and come back to the polystyrene. And it shows, you know, a different mass because we changed the density of the material. Let me go back and undo what I just did there because I don't want my density to be wrong. So that was under Rocket, edit database, materials. Come down here to polystyrene, come here to the edit button. Oops. I think I got to select one first. Okay, what's it locked up on me for? Oh, see, it popped up a window, but it was behind. That's not good. Polystyrene, edit, and it was 65.5. hit tab and hit done and OK, and then things should be back to normal. Change the thickness, material, calculated. I saw the mass change down here. Let's change it to balsa. Yeah, so if you change it to balsa, the mass really drops. If you change it back to polystyrene, it goes back to what it was originally. So everything's working fine. All right, so hopefully that answers your question about how to adjust the mass of your rocket. Johan says, I always add mass component of weight not counted for the fine-tune my simulation. So what Johan is saying, there's actually another way you can do it. You could just add a mass object into the rocket to get it up to 100 grams. And as long as the center of gravity is in the right spot, that works really well too. So to do that, I got up too early today. It's been a long day. Take a drink. Maybe that'll help me. A little thirsty. So you could like select the component in the parts tree, then come over here to mass object, add a mass, and see right now it's looking in the database for some mass. And I'll just cancel out of that. I can just override it by just giving it a mass. Like if I give it like 4.8 grams, that should bump this up to 100. See, it bumped it up to 100, and now all I have to do is make sure my center of gravity is in the right location. So then you just play with the location until you get the center of gravity right. And if you need to move it further, you can just type in a number. So I can type in like a 15, and it moved it 15 inches back from the front of the owning part. And that's how you can adjust where your center of gravity is, like really fine-tuning it. Fatbank says, Tim, burning the midnight oil? And it's yes. I got a lot of cool projects going on, and they get so exciting that sometimes I stay up a little late. And I'm a morning person, so even if I stay up late, my body says, time to get up, Tim. And if I don't get up, we got a cat. And the cat wants to be fed. And she's got an alarm clock that she's up every morning. Johan says, Michelle also yawns. I know we are boring. No, you're not boring. It's just sometimes when you're stuck in this little room and there's no air flowing, and yeah, it's just, and it's after lunch for me. So I had a big lunch, and yeah, sometimes you get that tryptophan kicking in that wants to put you to sleep. Okay, any more questions? No questions. Awesome. Let's see what we can play with then. Save your changes? No. I'm going to open up the launch visualizer. New window. Lots of microwaves are also good for you. I don't want to fry my brain. Okay, so I'm opening up RockSim.com. So you just go to RockSim.com, and this is the launch visualizer. And if you've never been here before, this is where you can do simulations. You can do them for free. So it's like here we have an avion. So if I wanted to run an avion, I could run that simulation, or I could choose something that's in the database. So I can select a rocket design and choose it right here, and you can see what's in the database. And this is all the free rockets that we've in the database. We can't put a lot of them in the database. It's just because it's a memory issue, because every time we get a new user, it allocates a certain amount of space on the hard drive for the user's data. So you run a simulation, and it's generating all this data. Well, that data has to be stored somewhere. So the more rockets there are in your database, the more information and size it would take up. So we are limited on how many demo designs. But once you create an account, if you log in and create a free account up here, then we can store a lot more data. And I think you're allowed an additional 10 more rockets of your own that you can upload. And then if you want to be on the paid version, you can upload an unlimited number of rocket designs. So like if I log into my account, you'll see that I got a lot of them in there. So if I go to choose design right here, just click on that. And then you can see I can just scroll through so here's the demo designs that I just showed you. Here's the my user designs. These are ones that I did specifically for me. Here's an airmail rocket. The airmail is this rocket right here. And let's run a simulation with that. So I'm going to select that one. And it loaded it here, and then it loads it on the launch pad. And this is 3D, so you can rotate it around. So I'm just doing a click and drag with my mouse. It's a right click. If you do a left click and drag, it kind of pans the camera that's looking at the rocket. If you right click, you can rotate and you can look down on it. So we got a rocket, and I need to find a place to launch. Anybody got a recommended launch site? Fat Bank says, any comments on the Artemis launch on Monday? Okay, well, we know where our launch site is going to be. Let's launch from the Artemis launch site. I'm not sure what pad it's going to be on. So right here we have a map of the Earth. And let's look at it in a 2D, looking straight down on it. And let's find, can I make that bigger? Yeah. Let's find the launch pad at Kennedy Space Center. Okay, so here's the United States. Down here is Florida, so I'm zooming in. Okay, so here is, see, I used to work here at Cape Canaveral. This part of the Cape is actually two parts. Cape Canaveral is the southern side, and Kennedy Space Center is the western side. So this area up here is Kennedy Space Center. Let's see if I can find my old house. This is the town of Cape Canaveral. That's where I used to live. I used to live on Monroe Avenue. All the streets were named after a president. So you got Washington, Adams, Jefferson, Madison, Monroe, and they're in order. So you can learn the order of your presidents, which I always thought was a cool idea. And I lived right across the street from this baseball field right here. So that red building was the building that I used to live in, and I was 1 block, 2 blocks, 3 blocks from the beach. I miss the beach, but Florida doesn't have any mountains. Yeah, and then I would drive into the Cape along this road, and I worked at Launch Complex 17. Which was, I think it was this one right here. Yeah, on Lighthouse Road. And then here, right here is the Air Force Missile Museum, which is a really good museum if you ever get a chance to go visit it. You can kind of zoom in, you can kind of see some of the rockets on display here. This right here was the launch pad for the first launch of Alan Shepard in the first Mercury flight. And our launch pads were right over here, so it's kind of like a stone's throw away. And anyway, well, we came here for to launch rockets, so I'm coming up the Cape, and I'm not sure which pad Artemis is launched from. It's one of these two pads. But we can launch there too, here in the launch visualizer. I'm zooming in. I'm assuming this is the flame bucket here where the flame is going to come out. So let's like put the launch pad right here. So you just double click on it and confirm the launch site. And when you do that, it says that we're 87 feet below sea level. All right, so we got the airmail rocket, which is this one right here. We're going to launch that one from the Artemis launch pad. So we've chosen the launch site. We have to choose a starting state, and we're going to launch to the east. So I'm going to angle my rocket. Let me move this a little bit smaller so I can see the controls. So I'm going to angle it to the, oops, I'm going to the north. And I need to go to the east. Okay. I guess that's okay. We'll leave the azimuth or the starting roll rotation alone. This is fixed to the earth, and let's see if we'll give it a little bit of wind, so maybe I can get out of the launch area. Steady wind at let's make it an even 5 miles an hour. Hit tab, click OK. Now we need to select our rocket motor, and the rocket motor will, like RockSim, the motor is right here. We have an 18 millimeter motor tube diameter, and right now there's no engine in it, so I'm going to hit choose an engine down here, and we'll choose an Estes C65. So you choose your motor, then you choose your delay, click OK. So now the motor's loaded. We'll check our parachute, and the parachute is by default it's set at maximum ejection delay. So that's okay. And now we just launch. And so I think the launch button is covered up by my face here on the screen. So let me move that just that way so you can see the launch button right there. And I'm going to click that and launch this rocket and simulate. And it's running the simulation, and then it shows the rocket. I have to zoom out a little bit because my resolution on my camera, or on this image, is a little bit grainy, but my rocket is right there where my cursor is. And my goal in this launch is to see if I can make it past into the tree line. I don't think I'm going to make it. Anybody want to guess? Am I going to make it or not? I'll pause here for a second and not run the simulation until people make a comment on, make my prediction. Am I going to make it out of this using an airmail rocket launched from right in the middle? Am I going to make it into the tree line? Yeah, we'll find out. Johan's Fatbank says no. Carlos says, he's got a really good comment. He says, the launch visualizer shows NAR and Tripoli launch sites as red and blue dots. Did you ever consider adding green dots for hobby shops selling Apogee rockets? There is a green dot in the launch visualizer, and I'll show you that in just a second. But they are not associated with hobby shops selling Apogee rockets. There's not that many of them. I don't think, I couldn't list any off the top of my head. I know there are some, but I have no idea where they are. Okay. Johan says, how big is it? Probably huge. I think he's talking about how big is this area right here. Well, as a perspective, there are some vehicles usually parked along the pad somewhere. Let's see if we can find a vehicle. So here's a car right there. Here's another car. And so our rocket is right there. And it's aimed to the east. All right, we're going to launch it. Okay, it goes 65 seconds, so it's going to be in the air quite a long time. And the rocket has taken off, and you can see the smoke coming out. It's still thrusting. Okay, we lost our thrust. It's going up. We're at 500, 600 feet. And somewhere around here, the parachute should pop up. So the parachute is out. And we've got the wind going from the west towards the east, which is not typical of Florida because usually the wind is coming off the ocean. Let me pause it right here. Let me give you the ground track. Let me turn that on. Here's the trajectory path and the extruded flight path. So this is like the ground path right here. Click OK. And let me turn this off. So here's where our launch site was. I think we might make it. I think we will. All right, let's continue the flight and see where it lands. Johan says, oh, it will make it. Yeah, unless the wind all of a sudden stops. I think we're going to make it. But we're not going to make it to the beach. Okay, we're almost to the end of the road. And yeah, I think we're just going to get into the marshes there. It's a very wet and soggy area. So yeah, it's home to a lot of alligators. And I'm trying to get it all the way to the end. Yeah, we did make it out into the scrub. So how far away is the beach? Oh, we were only about a quarter of the way to the beach. So we need to go about 4 times higher. So if we go with a D motor, we'd get twice as high. So we might get out here. So we need about an E motor to get to the beach. So let's try that. Let's see if we can get to the beach, unless there's any other questions. Oh, I wanted to show you, before we do that, the green launch pad locations. So the green ones are user-defined launch sites. So I could put on here launch pad at KSC, Kennedy Space Center, and then do save this launch site, and it chose my name, and it tells me the latitude and the longitude, and is permission required to launch here? And I would say yeah. You might get kicked off the Kennedy Space Center facility if you don't. Is this a Club rocket launch site? No. And you could just say launch pad 39, hit submit. Okay, so now it's saved into the database. And so if you go to choose a launch site, you'll notice there's a public launch sites right here, and then the private ones right here, and you can see that all these private ones are green. And then here, the one that I just added, Launchpad at KSC, is also in the green. And click cancel. There should be a green dot. Let me do I'm going to do a refresh like I'm just coming to the website for the first time, and let's see if it's in the database, and it should show up as a green one. So choose a design. Here's the error mail again. Click select. If I go to launch sites, and if I zoom out, it's got to load the map again. See, there's red ones and blue ones. Oh, here's a green one. Oh, I'm not seeing a green one here. Oh, these are public launch sites. All the ones that you see when you first come to it are public. If you want to find your private one, you have to choose a launch site and go to the private tab and scroll down and find it. Click OK. And then it loaded me right here in Florida, right into that same spot. Now, if I wanted to share that launch site, then I would go here to share the launch site, and this is going to make it public. Okay, so this one here, Launchpad at KSC, and if I say make it public and share, okay, so now it's been shared, and it's post approval from the admin, it will be made available for the public. So what I have to do is go into the back end, turn it to public, and then it will be a green pin. So let me do that real quick. I have to go off screen, so because I have to do this in private. Oh, look at this. Okay, I'll show you something. This is something you won't see very often. This is my admin dashboard, and I can see that's what here. Approve the launch sites. So here's my launch site, Launchpad at KSE. I can either approve or reject it, and I'm going to say approve. And now it's approved, and as soon as this lets me log out, I'll log back in. Oops, wrong one. Not that one. This one. I got multiple users. Okay, so choose my design. Select it. Okay, so now go to my launch site. So now I should see a green pad or green pin at Kennedy Space Center, because this is now public. I'm zooming out. I'm still in Colorado. Okay, so there's the green pin right there. And if I hover over it, if I click on it, it'll say Launchpad at KSC. And so then I can come here, and this one will be in the public launch sites now. But you have to scroll all the way down to the green section. And it will be, actually they're listed in order that they've been approved, and so it will be on the bottom one. So if you are on the launch visualizer right now, you could follow along. So now it's set my launch pad right there again. If I zoom in, yeah, so there's that launch pad. All right, so let's put an E engine in it. Again, let's set my starting state. I don't remember the last time what the angle was. I know we had a wind of 5 miles an hour. Oops, not variable. Cancel that. We want steady wind. That was at 8. Let's go 5. Click OK. Okay, so we're going to choose an E motor, And if you go in here by default, for 18 millimeter engines, there's no E's. But I don't have to choose an 18. I can say show all the engines. And now, come on. Come on. It kind of froze up on me. And the only way to unfreeze it is to do a refresh of the page, which means I got to reload everything all over. Unless I'm having internet problems, which is totally possible. Because now I'm getting the spinny ball like it doesn't want to go there. Oh, there it goes. It was internet problems. It wasn't the web page. Am I still logged in? I'm still logged in. Choose a design. I want to see if I can get there. This is fun, unless there's a question. Johan, he's laughing. He says, Kennedy Space Center public launch site. Ha ha. It is a public launch site, but it's public in that the citizens of the United States own it because it's government property. Choose a launch site. Launchpad at KSC, click OK. And then we can go, let's see, it's loaded it right there. I'll go 24.5 and launching to the east. Wind, 5 miles an hour. Now we're back to where we were before. Choose an engine. Show all engines. Oh, it's freezing up on me again. There's something going on. I'll let it sit here for a second because the last time it unfroze itself. Okay, I guess it was slow because it had to load all the motors. So now I'm going to go manufacturer filter. Let's go Cicerone, just because there's fewer Cicerone engines. And sort it by smallest to biggest. So here's an E22. I'll choose the E22, select the delay. We'll make it a custom delay and use 8 seconds. Although I'm going to kind of hedge my bets a little bit here. I want to deploy the parachute at Apogee because I want the best chance I have for hitting the beach. So under flight events, I'm going to go for the event description of the parachute. Instead of using the max delay, I'm going to say deploy at Apogee. So now the parachute will pop out right at the top and give me the best chances of hitting the beach. So now let's click here to launch and simulate. And we're going to take our bets. Am I going to hit the beach? Am I going to be in the water? All right. The rocket's loading up on the pad. Ooh, 123 seconds. It's going to be in the air a long time. So there's the rocket on the launch pad. Let me make sure I got my ground track. Extruded flight path is turned on. Okay, let's get a larger view here. So I got to get from here to here. That's my goal. Yeah, let's launch. And let's see, the rocket's taking off. Oh, it burned out really fast, but it's coasting upwards. 1,400 feet, all 1,500 feet, and there's the parachute right there. The red dot means that the rocket, the parachute came out when the rocket was outside of the weathercocking cone. So technically this is not a good launch. And it does seem like it's dropping pretty fast here. If I go from the side, I don't think we're going to make this one. I didn't get high enough, so I'm going to drag it along, and we'll see where it lands. I'm not even, I only made it halfway, so before I landed here, now I'm landing here. I got a long way to go. All right, so we're just getting ready for the Artemis launch and what it would be like to launch a model rocket at the same time as the Artemis. Yeah, so by this time next week, hopefully that Artemis will have taken off, and hopefully it's, I don't know, they're shooting out pretty far, so it should be fun. There's no, Fat Bank says I would trade gators for sharks. You want sharks? It depends where your rocket's going to land. If you know it's going to land here, I'll say, oh yeah, I'll trade the sharks for Dake, because the sharks would be no danger of going to chase my rocket. All right, so we had a lot of fun. We're getting ready for the Artemis launch. We're launching rockets from Kennedy Space Center today. This just shows you the fun you can have with the launch visualizer. Just, you know, trying out rockets with different motors from different launch sites, seeing what you can accomplish, seeing if you can get the rocket back. We were trying to lose the rocket by putting it in the water, but it's a virtual rocket, so it didn't matter. So, next week, like I said before, we're going to try something a little bit different. We're going to do what's in my range box, just kind of talking in general rocket stuff, kind of behind the scenes type of thing, and why I have certain items in my range box. And it'll shock you what's in my range box. So until next week, go out and fly something. So 5, 4, 3, 2, 1, ending the stream.